You're going to see here today is myself and Gary are going to be connecting ERAs, electronic recording ammeters, to the different feeders at the Wellesley DS. Technical services requests that we connect these to monitor and record the loading on each feeder. We'll take the existing ERAs that are hanging on the feeders and download the data onto our laptops. Then we'll take that information and we'll send it off to technical services for them to evaluate. The purpose of it is for technical services to have an accurate read on what the load is on each particular feed. The ADETs are basically the eyes for technical service. We're the eyes in the field for them. We'll come out and gather all the information they need and send it back to them.
Provincial Line Technical Service, we look at the direct impact of something on our distribution system, either it be a new generation coming online or load transfer. From the field's perspective, they don't see that the information that they gather has a massive impact on what we actually do. We actually take the information that they're getting from their ERAs and implement them into a model which gives us basically a simulation of our distribution system, and then we make protection settings based on that information.
Without our involvement in these planning activities, we could potentially see equipment overloads in the field, which could cause unnecessary burnout of conductors. We could see equipment not operating properly. With the tools and technology that we have in place, we're able to make sound decisions.
Our group does do a lot of distribution design work, but it's from a central location. We apply the underground distribution standards and we use those to create an optimal subdivision design.
We're actually assessing outside of the subdivision to the whole area, so all the supply feeds that may be incorporated in that one subdivision. We're looking at how we can efficiently supply without impacting any of our voltage conditions on the feeder.
Like when an ADET or a field guy gets a work spec and he just sees that to put a fuse or that they're putting a recloser in, they don't really realize the amount of work that went into that work spec. That back here we're running all these simulations and coordination studies to figure out what fuse should be going there and what the recloser settings should be.
If we didn't provide our services on any one of these planning projects, there could potentially be standards not being followed to what they need to be, but ultimately we could be impacting our customers. They could be seeing dimming lights with large loads coming on, or experiencing outages, which we don't ever want our customers to experience.
Without our efforts, the work would get done, but it would be inconsistent throughout the province and it might not have the planning input, which could lead to power quality issues or other issues to the distribution system.
With the technology changing in the field, it's nice to have the younger people that are up on the changes and the advances in metering. And yeah, I certainly use technical services. I'd say every week I'm talking to either Matt or Darren or Mancy down at Technical Services. They've researched it quite in depth, and they know when we have questions, they're excellent to get back to us and answer the question. They're great at troubleshooting for us. We certainly rely on tech services to solve our issues that we have in the field and to provide us with a good quality product that we need. And in this case, for complex metering, they certainly have.
So we do get a lot of calls from MDOTs in the field. So let's say when they're commissioning a metering installation, they can call us up at any time and we can answer their questions, or if they have any issues any field related issues. We also deal with other things such as investigation of meter failures. Then there is approval of new equipment. So for example, primary metering units, so the CTs and the PTs that they're using, we would go through the approval process of it. So much like distribution standard, we would look at see if there is if they're CSA and ESA approved.
Our group here basically maintains the database. We take all the different sources that come in, whether it be mobile, whether it be from CAD groups, whether it be from the ADET population, and we massage it into a way that makes it readily accessible for the rest of the company. The different user groups are our ADETs, our engineering studies groups, our metering groups, GORMs, we have people of forestry, as well as the planning groups. Having data of this type at your fingertips allows you to make decisions from your desk or from the cab of your truck that helps you to increase your performance. About 6 years ago, we were mandated by the OAB to patrol 1/6 of our total assets every year. So we started out with the impression that we had 1.2 million poles. We quickly realized that we're approaching 2 million assets on the distribution side, specifically just for poles. We also have transmission information and forestry information that is being leveraged by the Geographic Information System, which we refer to as the GIS. We have a program that has evolved over the last 7 or 8 years where we collect asset and condition information for distribution, transmission, and forestry. This system allows us to integrate asset information with GIS and SAP into one robust database that the company can access. So the GIS gives us a very definitive idea of the location of the asset as well as the type of defect. So the planning group uses that information to bundle work packages together. Yeah, this system allows us to plan our projects more efficiently. So we're trying to reduce the number of truck site visits so that we don't replace one pole at one location and return a week later to replace an asset 50 feet away. So we're trying to group our assets spatially, and that allows us to get increased efficiencies. If you're a lineman, for example, having pole information on a storm, say you're from a different area, normally you would be sent to locate a switch where there's an outage. We've loaded the data into the Garmin units. It allows you to enter the switch number, and it takes you there by turn. A typical scenario would be, say, if you have an outage on a lake, the line goes sub-cable, you have the switch on one side, and you have a crew that's unfamiliar with the area, wandering around in the dark with flashlights trying to locate the switch. Having the GIS data, we know that you should be driving around the other side of the lake to access the switch in a timely manner. Technical Services is constantly looking for ways to be innovative, to take this data and deploy it in easy-to-use, meaningful ways. So whether you're in your boat, whether you're on a snowmobile, whether you're flying in the chopper, whether you're in the cab of your truck, having information that is as near to real time as possible. Without information of this type, it makes it very difficult to plan these types of projects with any type of efficiency. So having information at your fingertips allows the business to make smarter, more efficient decisions.
When it comes to Regulation 2204, Tech Services is a major player with respect to interpretation of that document. Tech Services does produce a HODS document which covers, in layman's terms, to ADETs and linemen the interpretation and the minimum requirements of Reg 2204, and we consult every day with linemen and ADETs who have questions about meeting the regulation. The field will always come to Tech Services with challenges, whether those challenges are non-standard or they're material challenges or other just general products and questions. These challenges and these problems are reviewed by Tech Services, and that's how we provide support and value to our organization. That ADET may come in with a problem and make one comment to me, but there's a whole team that supports that problem and solves that problem so that when the ADET, say an ADET on the other side of the province runs into the same problem, they're able to do it to a standard, do it safely, and do it the most cost-effective way.
Our distribution planning group looks after putting out the fires that happen day to day in the field. So we're looking at short-term planning solutions, whether it's resolving power quality issues, resolving loading issues on feeders, and dealing with our field contacts to resolve issues. But we do also get into the long-term planning where we deal with larger scale project with DGs where protection settings need to be approved for those customers, but also in the subdivision world where we're connecting thousands and thousands of homes, our group is looking at the overall picture and what we can supply in those situations.
On the Omnia project, we had several unique challenges, including oversized conductor, long spans, which are where our wood poles wouldn't support it, as well as DGs going in. So we had to manage all those different factors.
This pole, as you see it in front of us here, was originally designed with 7.5 feet of separation between the 44 to allow for conductor gallop. We don't have any known cases of that in our area. So when we go to redesign this, they'll look at decreasing the separation between the 44 circuits from 7.5 foot separation down to 6 feet separation to allow for decreased pole height. There may be the requirement to increase the separation to the rural underbuild because of the sag of the 795. And in addition to the transformer weight, there's also the bell cables on this pole. So our standard 75-foot class 1 that we have in front of us is insufficient by today's standards. So we'll be in touch with Tech Services to have them assist us in completing a pole class calculation to ensure that the pole we replace this with is of suitable class. One of the driving factors of why we're replacing these KMS poles with composite poles is the extensive woodpecker damage. The pole in front of us here has been filled twice already. As you can see, there's 2 holes that have been filled with the epoxy, and on the back side the woodpeckers have been added again, and there's a couple new holes there as well. So replacing these poles with wood poles just doesn't make sense due to the cost of the poles themselves and the cost and the labor to install the hole and do all the transfers. So they've decided locally to replace these poles with composites.
So Tech Services was responsible for developing the specification for the composite pole. They're responsible for reviewing the strength of the poles along with the associated materials for the pole. We then created the standards in which everyone sees in our overhead standards books today. When Tech Services introduces any material, there's a ton of work that goes into it. The field only sees the end product and usually say to us, well, why couldn't we get this 2 years ago? But we do a lot of review of testing, pilot projects, review of specifications, writing of specifications, the tendering process, and then writing the actual standard that gets released to the field.
Within a 3-kilometer stretch of Crosby TS, we do have 3 10-megawatt DG projects on the go. Each of those projects required a 1-kilometer expansion of the 44 to get to their sites. The M1, M2 feeder feeds one customer. It's a large crushing facility in the Perth area, Omnia, and they're actually being currently backfed out of Smith Falls TS. So Tech Services were involved with doing our load studies, our planning group as well. They look at the load that's currently on the M1 out of Smith Falls to see if it'll support the load of Omnia and whether a transfer can be done.
Our group's role is kind of unique within technical services because we provide an actual design role similar to what the field does. However, we do it in a centralized fashion. So we're dealing with developers in Ottawa, Essex, Kenora. So what we're trying to do is drive consistencies with the way subdivisions are handled throughout the entire province. In the case of Stouffville, it's a large area. So what we need to do is we're working with multiple developers, but we work with the DX planning group in order to provide design that's optimal and also gives us what we need in order to make sure it's fed properly.
Yes, 10 years, there's been so much growth in Stouffville here that they've, just in the last year, we've had to put another bank in at Ringwood to accommodate all the growth. Ringwood DS was expanded to probably another 40% of its capacity to accommodate all the growth, whether it's residential and commercial. Yeah, and there's still more to come here yet. Tech Services helped us out a lot of the old infrastructure that we had to deal with in replacement. A lot of substandard stuff that now we had to bring up to our standards. Tech Services because it was different, they had to design us a lot of the egress of the station to get out to our main line. Egress would be the point of the exit of the station to our cables and that get out to our main line, and the design that it has to take. Any of our construction that has to go on, whether it's overhead or underground, there's a design that has to be approved, and they will do that design for us.
This is one of the many examples on this job where we've had to get a hold of technical services for a non-standard application. The line here fly taps, which means the lines tap but not on a pole, they tap mid-span. And this existing pole does not meet standards for clearances, and it's just not something that would meet Regulation 2204. So technical services, regardless, are going to need to spec for us what the clearances between conductors are, and actually all 4 poles surrounding this intersection, and the spacing and the height of those poles. So right now you'll see a tower crossing where we have one 44 circuit and one underbuild circuit going underneath the tower line on crossarms. And we now need to get a second 44 circuit on those poles. So we go to technical services and they're helping us with span length, with clearances, and just a standard period, because our standard book does not show 2 44 circuits on crossarms.
A lot of things regarding our standards, our policies, our procedures that doesn't capture all the situations that we encounter on a day-to-day basis. And my role is there to facilitate, to help them get through those hurdles and to move the project along. I'm the single point of contact for all ADETs, SDETs, lines, FPCs. I take phone calls, I get emails, they have questions that I need to respond to help them move through a phase of a project or get over a hurdle that they're encountering on that particular day. So my whole function, 100% of my job, is supporting the ADET, supporting the field in order to move projects along.
In Newmarket projects and Metro Lines projects, we deal with Vince on a pretty much daily basis. For non-standard requests, for things that aren't captured in the distribution standards books, he's our gateway to dealing with real estate when our standard offer to grant document doesn't cover the situation. If we need to deal with legal, with getting any kind of a letter written up, Vince is the man.
I think the rest of the lines of businesses in our company really only see the tip of the iceberg. They don't see all the upstream work that our group is putting into making day-to-day operations and long-term planning solutions happen effectively. The efforts of technical services in the back end ensure that we're making the field's work, being the linemen and the ADETs, we're making their jobs safe, and we're also making their jobs operate as smoothly as they can.
Well, if there weren't new protection settings made or load transfer went on without anyone studying it, either voltage at the end of the line would be way too low, you could have massive overloading, protections wouldn't work, so they would just trip off an entire TS, which would put thousands of customers out of service.
Okay.
Where with a wood pole, it's more likely to snap once you get to applying a larger load to it.
And there's very few utilities in North America that have a system as robust, considering Hydro One's expansive land base. It's taking us close to a decade to capture and maintain this information.
There are a lot of people that know a lot about Reg 2204 and Hydro One, but I feel Tech Services is, we may not be the only people that know about it, but we're definitely a major player in that area, especially when it comes to support of the field staff.
Good.
What we've done here, we've isolated the cable feeding the next transformer up, and we're going to be sliding in other cables, secondary cables to the one to the north. So we had to isolate that transformer, so we isolated here on the cable.
This has assisted us on a lot of any upgrades we've had to do because of the regulation we've had to follow. And even in the upcoming future, some of the old stations or the infrastructure there, that they will be a key role in designing, let's say, the stations or what we have to do to upgrade.
Go for it.
So I guess starting from the from what the ADET in the field may see, when they're sent out to do a preliminary investigation for determining entrance points into subdivision from our feeders, that information is coming back to our group and being dealt with both by Corey for the subdivision layout and design, but also from distribution planning's end to look at the overall picture and how these large-scale developments may fit into our system and how we can properly plan and maintain quality and reliable power.
CAD services providing us the data, and then we assemble the data here, we massage it, we put it in the proper format, and then we can print maps, but now, like, technically we're not doing it, but then we could print maps. So anyone can dive in this system right now. Let's say you live somewhere, right? You can dive in the system right now and see the feeder configurations around you. Mm-hmm. So we'll have the parcel fabric coming in from external agencies like the municipalities and the DMTIs and, you know, the MNRs, and we can see your address, we can see your lot size, and we know the meter, we know the secondary overhead, we know the connection type. We won't be able to see the bills and all the customer aspects, but then we'll see the engineering aspects, how it is being fed and from where it is fed. So in case of a fault, you know, it can be traced back to the nearest tranny, nearest transformer, nearest switch, or in case if the whole feeder is out, we can notify you and a couple of other customers. So it's a complete mishmash spaghetti of everything electrical. So we have got in another system, not here. I think the TLGS is run off another group, but then they have the transmission lines, and we have the sub-transmission and the distribution lines. So technically, I mean, you know, we have an end-to-end trace.
So they'll come back to us, and we'll probably get a request to go out in the field, and we could be changing a concession from a white to a blue phase because it's loading and they want to balance up the feeder. And what it would do is balance that feeder out, and that's for the whole station.
No, this is just a make-ready that I've done through ArcFM with an AutoCAD design overlaid on top of it, and it shows what the responsibilities of Hydro One is in this new development here in Stouffville. The blue indicates what the developers' contractors are required to do as far as excavating, overdigging existing trenches, installing primary, secondary cables. And in the red, that just shows what Gary's team will take care of as far as the final connections inside the kiosks, transformers, as well as performing isolation prior to any of this work happening. And then once this is completed, it'll be sent off to the subdivision group, and from there, if there's any non-standard requests of any nature, that'll be sent off to, I guess it would be to the non-standard group, which is part of technical services. And all that, it's usually, from our end, it's all usually funneled through our senior technical officer, Vince Limina.
This helps. all of our line staff to get directions to all of our assets that are housed in the GIS, being poles, transformers, switches, and makes it easier for them to navigate to their location rather than using paper maps or by memory. So it also helps in storms where they're receiving help from other areas and they have linemen that come in that are not familiar with that area. They're able to use this device to get them to trouble spots.
Well, Al, from a project standpoint, unique part is there's 3 big solar farms all going in here within a radius of 5 kilometers to each other, and they're all connecting to a double circuit 44 kV line. And the unique part about it is it's 795 conductor, so it's heavier to work with, higher tensions, and that, and the roads are narrow, the traffic is heavy because of the 3 solar farms all going in there. There seems to be a lot of construction traffic, so we're flag people all the time, every day. And then from the line perspective, we're using apprentice crews, so it's a bit of a learning experience for them. A lot of things are new. Plus we're working around existing radial feed, single phase, so we need numerous outages to capitalize on the work that we want to get done in a day. A lot of the existing poles have been damaged by woodpeckers, so we're replacing them with composite poles, 70, 75-foot composite poles. Because of the high tensions, we're into double guying on the composite poles and trying to maintain the clearances that you need from the conductors, and that is a bit of an issue. You have to move the guys a couple times to get them in the right place. Needed additional tech support on this because of the oversized conductor and the taps that we're doing and the clearances. We've had to get some modifications to the distribution standard drawings to accommodate us on certain poles. Us, it hasn't made a lot of changes. At the TS, they've had to change the station transformer. PNC are in there changing a lot of relaying and that sort of thing in order to accommodate the DG.
Well, in order to take out Crosby TS and keep all the customers on, we had to transfer the Omnia load onto Smith Falls TS. In order to do that, we have to basically create models and run simulations to get the certain numbers.
Cycle studies are an OEB mandate that's funded by our counterparts in asset management for us to ensure that all of our distribution feeders are meeting the protection standards that our company holds. But at the same time as when we're doing that, we're also looking at the balance of our voltage conditions to ensure that we're operating our feeders efficiently.
Some close-up of this.
In the case of this Omnia project, technical services have provided us the expertise and the knowledge with the type of metering that's involved in a more of a complex, we call it complex metering situation, where with the solar farms coming on board and a 14 megawatt customer such as Omnia, it's not just an easy, sorry Al.
No, you're doing fine.
It's just not an easy house meter that we install and do the work in an hour or two. With this type of metering for this job, it's a bidirectional meter that it's called an ION 8600A, where the meter will see the load that Omnia is producing, and it'll also show the generation from the 3 10 megawatt solar farms that are coming on board. The best part about this type of metering for us is that it provides us with power quality information, that if there are any events on the line, that our folks in Toronto can download the meter, look at it and say, hey, we've had a problem on phase A, phase B, or phase C with the voltages, the currents, harmonics, flicker, any type of power quality issue. So it gives us automatic response that we can troubleshoot and solve the problem, hopefully for the customer. 3 years ago, Tech Services introduced the Ion 8600A to Hydro One retail, knowing that these challenges, we were going to face this type of problem in the field. So they've designed a standard for us to follow and provided us with the meter and the technical information, providing us training so we can install them. And they've also, with this type of setup, they've told us that, yeah, we can use this type of primary metering, the Ion 8600A, and they're there if we're out in the field and we're doing work. They can actually look inside the meter, what we're doing, and say, yeah, things look good, and we do a comparison with an end-to-end test as well. So
I am, in one sense, the tip of the iceberg when it comes to technical services. There are so many people that perform all different types of standards work that develop standards, creating new standards, and we see that a lot throughout the field and throughout our requests.